Hello, welcome to 𝔼𝕚𝕚𝕠, where I will train future civil and structural engineer. My name is Justice Umoka and I am your instructor. Today, I'll be showing you how to perfectly design a base plate using the software Prota 2026 version. Now you can see that on my screen here, I designed a base plate directly from the ProtaStructure environment and not using the ProtaSteel. That's because this new version supports that. And this designs your base plates based on any design code you are using, as long as you apply the common principle for that. Now, basically, this building is for a renovation. Basically, they are trying to add a steel shed just to create like a bar, mini bar around the hotel. So in that course, we have to do this steel shed over over what they're about to trying to do. So in this course now, let me now, although I've already designed few of the base plates here, but I left some just to show you guys how to design that. So I left this and then this here. So I'll be using this one to now show you how to design for your base plate. Now before you can begin your base plate design, you must have already done with your modeling and also performed your structural analysis and design as usual, which you can see here on my screen here. So if I turn on this now, you can see that we have already designed for this building particularly, and you can see all that here. So you must make sure that everything has passed. Okay, that is fine. And also your trusses, then you can then go ahead and then perform your base plate design, which you have to go to story 0 and also install and also insert your pedestal. So if I go to my story 0 now, you can be able to insert your pedestal after you're done performing your structural design or before that. Okay, that is fine. So in that course now, we will then move on to the base plate design and make sure you are on story 0. If you are inserting your pedestal, you will see that under this story 0 here, which you can find under modeling here. You can see a pedestal, which is found at the grade level. So to now design for your base plate, you can see that at story 0, the base plate is not showing, it's not visible. So make sure you are on the story 1 where where you modeled for the stanchions. Okay, that is fine. So you can see now that the base plate now is now made visible. So I will then come now and then zoom up to this place now, click on my base plate. Now once you click on the base plates icon under your modeling tab, click on this now here and then you click enter. Now once you have clicked on the base plate icon, click on the column and then press enter key, you will see this will appear to you. Now if it's the first time you have not done this, then you have to set it actually. Even if it's your first time, you need to do what, plan your settings now. Now this pedestal you are seeing here is 400 by 400 pedestal. And now whatever thing you're doing, put your eyes here. As you're moving, it will be doing the design for you, checking all the standard if they are okay or not okay. Now here must be shown what successful, all right, design successful, else it is not designed. Okay, that is fine. So in this case now, since your my pedestal is 400 by 400 based on this design, and my stanchion is HEB 180, and then my pedestal is 400 by 400, and the height of the stanchion or of the whole building is 6.5 meters high, which you can see around this place. Okay, no, 6.3 meters high, correct, 6.3 meters high. So in that course now, I will come here. They're asking you to put your base plate parameters. I will leave the materials as it is, which is the strength 327, sorry, 325, and then they're asking me what is the length of my base plate, knowing that I want to have grouting. So I will remove my grouting thickness and width of what, 25 what millimeter. So in that course now, if you minus that from that value, I will be having 375 instead of 400, which is because 400 is is this concrete pedestal width. So I will minus 25 millimeter grouting. I have 375, and I will make sure I have the same thing on the other direction too. As you can see that as I'm doing, they are changing. Now we then go to thickness of the base plate. So you can see what we have now. This allowance is for the is for the grouting, which you can see here. Now you can see that it has changed, but it's still failing. Then we now come to our base plate thickness, which is this base plate thickness. Basically, if you're designing for a base plate that is going to carry a shelter or something, you don't have to use base plate 10, although most times you can try 10. Most times 10 works, but I want to start with 20 because it's a base plate, and I want to use 20. Else you can also try 15. Let me say try 15, but most times 15 fails for a base plate, for a portal frame or something. So I'll use 20 for that. And then here they are now asking me, they are asking me now anchor bolt to anchor distance. Now what does this thing mean? You have to calculate this. And how do you calculate this? You calculate this by simple formula, knowing that your base plate thickness here, our base plate length and width is what, 375. Okay, now 375, and we are using a bolt diameter of 25 millimeter. Now based on the bolt to edge distance rule, which is the bolt diameter, which is 20 multiplied by 2.5, okay, that is giving me 50. So in that course now I have 50 as my edge distance from the bolt, right, from the base plate face down to the center of the bolt is 50 millimeter. So I will have to come here now. Since I've gotten my edge distance to be what, 50, I will minus 375, which is this base plate here, all right, minus 50, and know that we have, since we have both, we are going to have both here and both here. So I'll have to minus the first edge distance and the second edge distance. That's what, 50-50. Okay, so I will do 375 minus 50 minus 50 again. That gives me what, 275. I will come here now and put here 275, and then click below here, and you can see that they both have what, adjusted. Now we have taken care of the edge distance between here and here, but we have not taken the edge distance between this face and the center of the bolt on this other direction. So I will come again here, but in this case now we are not going to do the same formula by using 375 and all that, because they are asking here what is the anchor bolt to center. All right, anchor bolt to center. So you have to divide this base plate by 2 and then subtract that. So we have to divide this by 2 now. So 375, which is the base plate width, divided by 2, that gives us what, 187.5 millimeter. Now and we are using what, 50 millimeter as our edge distance. So minus 50, that gives us what, 1375, 137.5. So I'll come here and put 137.5, and I'll click on up here. So you can now see that we now have our bolt now being placed at the exact point. As you can see that, correct. Now you can see what we have now. Sorry, this is 1275, not 12 this. Okay, that is fine. Okay, so you can now see that we are now given what our edge distance now is now showing here perfectly. So the same thing now, but you can see that it is still failing. But I will now go and check why is it failing. But currently we are now on this place here. Let's now move to this other side, anchor bolt and stiffness property. So we then come here. We want to use a bolt of what? Of 20 millimeters. So I'll come and put anchor bolt 20. Okay, that is fine. It has been adjusted. I'll come and choose a grade of what? 8.8, class 8.8, because it's a base plate. So I'll come and put here and then click on what? Okay. And then they're asking me my bolt tolerance. I can choose to use 2 or 5 millimeter. Let me just put 2. And then they're asking me my embedment length. I can come and say, okay, I want to use 350 instead of 340. I put that right. Then they are asking me my anchor bolt projection, which is this. Okay, which is this. This other length here is the length that is the bolt going down from the face of the concrete downward. So I say 350. Why this other one now? They are asking me the bolt projection, which is here. I can choose to use 75, or I can choose to use 75 to like 100 millimeter is okay. So I can say, okay, 95 as my bolt projection. Most times, most people use 75 as their bolt projection, but don't just make it not to be too small. So let me just take 95 or 90. Most people 92, but that's okay. So in this case now, I will then come here now. I will then come here. You can see that, okay. You can choose to make this to be circular, but most times it is preferable to be square because it is best when it comes to what fabrication. So I'll use what square. And then I come here now. They're asking me what is my head plate. This is actually a tag plate, okay, tag plate. So for this tag plate now, it's best to usually leave it as 50 and also the same thickness. You can use 10 as the thickness instead of 20. Use 10. It is okay for that. We then move to foundation of that. For the foundation, it's already given you as a custom that the pedestal is what 400 by 400 millimeter, and the height of it is what 1000, because 700 goes down and 300 comes up. Okay, that is fine. So I want to use a grade of 25. For most times they use a grade of 30, but let me leave it to 25. And then they're asking me what is my grouting depth. I want to use 25 as my grouting depth. Okay, that is fine. So it is still failing. Before I can change to add stiffener or anything, confirm why it is failing. So I'll come here and then confirm why it is failing here under my result here. Now on the result, I can see that everything else is passing except this, which is the column edge failure check, and then anchor combined tension. Now there's a tension on this particular base design because of the height. The height of this is very high. It's 6 point something meters, and then and there is also a wind load added to this design, to this steel frame. So in that case now, since it is failing by shear, I will come back here under stiffener and property. So under foundation here, instead of using anchors, okay, anchors alone, I want to add like what can control my shear force transfer. Instead of using anchors, these anchors alone, I want to use shear log. So you can see that under it now there is no shear log under it. So I want to add a shear log under it. So I'll come and do what? Click on what? Shear log here. And then we will have our shear log added to this, which you can see here. It is time to check the design. Now it has passed design currently, as you can see that, because we have added a shear log. Now I want to choose my shear log profile section. So I will come now. Mostly they usually use the lowest section, which is HEB 100, all right, or the lowest section of the code that you are using. Okay, you try that first, and when it's okay, then that's okay. If it's not, increase to the next, but basically the lowest section is always okay for that. So you can see that I'm using the EU section, so I'm using HEB 100 as the lowest section, which is here, and then I'll come and click on OK here. That's fine. And then OK again. Now you can choose to apply the depth to reduce the depth to 100. Okay, you can see that it will reduce, but basically don't make it too small. Okay, so I will advise 150 to 250 is okay. So I'll just take 150 as it is. Then, knowing this now, you have to check for the thickness between now for this welding thickness of the profile itself. Now the welding thickness for this profile here, this is HEB 180, and the lowest thickness here is the web, which is what 8.5 millimeter. This is why the flange is 14 millimeter. So since this is 8.5 millimeter and then the web is 14 and then the base plate is 20, your welding thickness should not be more than the lowest the lowest thickness that is to be welded together. So along this now, you can see that we are going to weld the web and then the flange and everything. So in this case now, I will come and choose what 8.5 as my welding thickness. Okay, and you can see that they have increased. Don't use very deep welding thickness, else it will melt the lowest. It will melt the lowest like the lowest section size thickness. Then for the shear log now, I will use 6.5 because the lowest thickness for this one here, for this HEB 100 is 6.5, which is also the web, because you're going to weld the web too. So in this case now, we have done all this. We then come on here and then check our result again, and you can see that all our result now has passed. Okay, that is fine. this is not a failure. This is just telling you like this thing you are using, the code that you're using. So everything now has now passed. You can choose to generate your report and then move on to the next, which is here adding all this material, everything, and then generate your report here and then wait for that to finish up. And once it's done, you can then see your report perfectly generated here. Okay, so this is now the detailed report. As you can see that, and everything is there. And then you can check all your details. This is a very detailed report because I marked everything needed. So this is about 24 pages for just this part footing. So you can read all the details that you need there. And if there's any failure, you also see that anchored to you there. Okay, but in this case, you don't have any failure, which you can see all the loading combination, calculations, and everything that we needed. You can see that. So go through your report majorly once you're done with that, and then do that. That's fine. So you can see that, and then you can choose to save as PDF or just close. But in this case, I'll just close. So it's in a PDF, but always save as PDF. Okay, that is fine. Then come here and then close. That is fine. So in my next video, I will be showing you also how to, for example, you are designing. For example, you didn't design or modeled with this structure, but you want to design for the base plate. Okay, you can come here and put in your design forces and your design moments, and then design only for the base plate for the structure. For example, you performed your design, let me say using ETAB or any other software, SAP 2K, and then you want to design for the base plate alone. You can transfer those values, moment and the forces into this place, and then design for your base plate. That is fine. In my next video too, I will also show you how to when to use stiffener and that kind of stuff, because you know that we have pin connection, and then also we also have what, moment connection. Okay, that is fine. So in this case now we are done with the design. Okay, that is fine. Then come and do what, say okay here. So with okay now, you will see that our base plate will just appear just right here. Okay, that is fine. So the same thing you do for others, you do for that they have done for this, you also do for others too. Okay, that is just wait for it not what insert here now. Okay, that's you can now see our base plate now is now perfectly inserted here, which you can see here. Correct, that is fine. You can see the grouting, which you're going to do later by making it to do to like chamfer at site. Then you can also like to slope or chamfer, yeah, chamfer or slope. You can also see now if you have so many columns, okay, you can choose to do what, make them groups. As you can see that this one, I grouped all these columns and then design all at once. So if I select one, you can see that everything is selected. Correct. You can select most of the columns that are what, identical in height and also in their position, and then design all at once, which you can see here. And this one, that one too, was designed to as a group. This is that one here. You can see that as a group. Correct. So you can also group your base plate and then design for that. Okay, that's fine. So thank you so much, and God bless you. If you have any question regarding this, please comment on the comment section. I'll also reply you ASAP. Bye for now. And if you're a new subscriber, if you're new on 𝔼𝕚𝕚𝕠, consider subscribing. If you're an old subscriber, consider joining 𝔼𝕚𝕚𝕠 membership. And we are currently running 50% discount on 𝔼𝕚𝕚𝕠 mentorship training, which ends this month of July. So you can avail yourself on that and then enroll for that. Thank you, and God bless you. If you need any of our material, check on the comment section, or go to Google and type and search for 𝔼𝕚𝕚𝕠 store. You will get all the materials we use for our design. Bye then for now. And also you can also message us on our WhatsApp platform. Following any of our video, you will see our WhatsApp number down there. Bye then, and then see you on my next video.